When you lose weight, where does the fat actually go? Someone finally asked 150 doctors, dietitians, and personal trainers that exact question. 3 of them got it right. 3. Every single doctor in the room got it wrong. The most popular answer was that fat gets burned off, converted into energy. Sounds obvious. It's wrong. Others guessed it turns into muscle. Also wrong. The real answer is so strange that for about a century, almost nobody, including the experts whose whole job is your body, had bothered to work it out. You don't burn your fat, you breathe it out. And once you see how that works, and why some of your fat exists purely to set itself on fire, you'll never look at a fat-burning workout the same way again. Let's start with the weirdest part. Where does it physically go? In 2014, a physicist named Ruben Meerman got obsessed with this. He teamed up with a biochemist and did something almost comically overdue. He tracked every atom in 10 kilograms of human fat just to see where it ends up. Of those 10 kilograms, 8.4 leave your body as carbon dioxide, exhaled through your lungs into the air. The other 1.6 turn into water, which you pee, sweat, and breathe out too. That's the whole exit. Which means the main organ you use to lose weight isn't your stomach, and it isn't your sweat glands. It's your lungs. The paper says it flatly. The lungs are the primary excretory organ for weight loss. Your fat doesn't melt, and it doesn't turn into energy and float off into the universe. It walks out the front door of your face, one breath at a time. To see why, you need to know what fat actually is. A single fat molecule, a triglyceride, is just a tidy bundle of atoms. 55 carbons, 104 hydrogens, 6 oxygens. When your body burns fat, it's literally prying that bundle apart. Each carbon grabs an oxygen, becomes carbon dioxide, rides up to your lungs, and leaves on your next exhale. So weight loss is, weirdly, an exhaust problem. The fat is stored carbon. Breathing is how the carbon gets out. Quick aside, if weight loss is an exhaust problem just rearranged something in your head, subscribe. Quietly flipping over the things you thought you understood about your own body is the whole job here. Okay, so how does all that carbon get in there in the first place? Simple. You eat a little more than you need right now. Your body turns the surplus, especially excess sugar, into those triglyceride bundles and tucks them inside storage cells called adipocytes, fat cells. And you've got a lot of them, tens of billions, somewhere between 10 and 30 billion in a lean adult, more if you carry extra weight. Here's what catches people off guard. When you lose weight, you don't lose those cells. They don't disappear, they just shrink, deflate, sit there at half size, waiting. In fact, the number of fat cells you carry is mostly locked in by early adulthood. Put on a lot of excess weight as a kid or a teenager, and you build a higher number of them, a number that stays stubbornly with you for life. You can empty those cells out. You can't really fire them. And they're not passive bags of grease, which is what doctors assumed for most of medical history. Your body fat is an organ. It makes hormones, like leptin, the signal that tells your brain you've eaten enough. It's been texting your brain, liver, and muscles about your energy reserves this whole time. You were just never fluent. And where it sits matters more than how much you've got. The soft stuff you can pinch under your skin is relatively harmless, but fat packed deep around your organs is a different animal, metabolically loud, driving inflammation, insulin resistance, and heart disease. It's why a tape measure around your waist predicts a heart attack better than your bathroom scale. Same weight, 2 people. The one carrying it deep in the belly is in far more trouble. But here's where this gets genuinely strange. Because not all of your fat is even trying to store energy. Some of it exists to do the opposite, to burn energy on purpose as heat. Your fat comes in 3 colors, and they could not behave more differently. The kind we've been talking about is white fat, storage. One big, oily droplet per cell, barely any engine room, and it's well over 90% of your body fat. White fat hoards. Then there's brown fat, and brown fat is a furnace. It's crammed with mitochondria, those tiny cellular engines, so dense with iron they literally stain the tissue brown. Normally, those engines make usable energy, but brown fat carries a protein called UCP1 that short-circuits them, so instead of energy, they just throw off heat. Newborns are loaded with it because they can't shiver yet. It's how they stay warm. As adults, we keep only small stashes around the neck and down the spine. Evolution's built-in space heater. And then the strange third one, beige fat. Beige is a hybrid. Heat-burning cells hiding inside your ordinary white fat, lying dormant until something like cold flips them on. And here's the lovely part. Those cells feel the cold all by themselves. They don't wait for your nervous system to send the order. The fat cell itself senses the temperature and decides to start burning. Your fat making its own decisions. And this is where it stops being a settled textbook and turns into a live frontier. Because in 2025, 2 labs cracked open things we were sure we understood. First, a team at Washington University found that brown fat has a backup heater. For decades, we thought UCP1, that one rebellious protein, was the whole story of how fat makes heat. Turns out there's a second, completely separate system running alongside it. Another way to burn calories nobody knew was there. The second one genuinely rattled people. Meet HSL, hormone-sensitive lipase. Since the 1960s, we've known exactly what it does. When you fast, adrenaline switches it on, and it cracks open your fat droplets to release the fuel. Textbook. Done. Except there was always a paradox nobody could explain. If HSL is the enzyme that breaks fat down, then animals born without it should get fat, right? They don't. They do the opposite. They lose almost all their fat tissue entirely. Switch off the fat-burning enzyme and the fat vanishes. For 60 years, that made no sense. In 2025, a lab in Toulouse figured out why. HSL has been living a secret double life. Out on the surface of the droplet, it burns fuel, exactly like the textbook says. But it also slips inside the nucleus, the control room, where it quietly keeps the whole tissue alive. When you fast, adrenaline calls it back out to burn fat. In obesity, it gets stuck in there, trapped in the back office, unable to do its other job. Too little of it inside, and the tissue falls apart. Too much, jammed in the wrong place, and things break a different way. Which hints at something almost poetic, that obesity and its mirror image, bodies that can't hold any fat at all, might be 2 ends of the very same broken dial. So let's come back to that breath. Every time you exhale, you breathe out around 9 milligrams of carbon, tiny pieces of what used to be your fat, roughly 17,000 times a day without thinking about it. And here's the real punchline. The thing that limits fat loss isn't willpower, and it isn't some clever diet trick. At the most basic physical level, it's how much carbon dioxide you can move out of your body. That's why exercise works, not magic. When you breathe harder and your muscles demand more fuel, you're physically shoving more carbon out into the air. Anything that genuinely raises your metabolism, moving, being cold, even fidgeting, exhales a little more of you. And no, before you get ideas, you can't just breathe fast on the couch and melt the fat off. Breathe harder than your body actually needs, and you don't burn anything extra. You just flush out too much carbon dioxide. And here's the irony, after everything we just learned. Drop your blood CO2 like that, and the vessels feeding your brain clamp down, which is why overbreathing makes you lightheaded and can even make you pass out. You have to give the carbon a real reason to leave. But the picture itself is kind of beautiful. Your fat was never a curse or a punishment. It's a living organ that stores your energy as carbon, heats you when you're cold, and talks to your brain all day. And when you finally lose it, it doesn't melt and it doesn't vanish. It leaves the way it always quietly threatened to, atom by atom, breath by breath.
I'll be back.